Good afternoon, all.
Good afternoon, sir.
Is am I audible clearly? ऐकू येते सगळ्यांना व्यवस्थित?
Yes, sir.
Okay, we will wait for 2 minutes and we will proceed. So I think in previous lecture we have completed compressors, because actually 3 to 4 days gap is there, but I have not conducted lecture on division G. So please see where we are. Okay, so we will start now. So where we are? Can anyone please help me? Hello? As per my knowledge, we have completed that compressor.
Yes.
Okay. So we will proceed for the next device from this. Actually, on another divisions, these turbines are also completed. So in this chapter, mainly 3 type of devices added. In that, first one is the pump, second in pump, single acting reciprocating pump, then double acting. So double acting reciprocating pump, then centrifugal pump, then another device is the compressor, in compressor, reciprocating compressor, and the vane compressor. But these all devices are power absorbing devices. Okay, to perform their function, they need external power source. Okay, now if all devices require power source, it means somewhere at some point power production should be there. Okay, so there are different types of the power production, what we can say, plant, out of which the very important plant is the hydroelectric power plant. Okay, त्याला मराठीमध्ये काय म्हणतो आपण? जलविद्युत प्रकल्प, बरोबर ना?
सर कॉम्प्रेसर झालंय सर?
हा, झालेत ना.
म्हणजे झालंय का?
ओके, कॉम्प्रेसर झालेत. तुमचे डिव्हिजन फक्त मागच्या 3 दिवसामध्ये बाकीच्या डिव्हिजन वरती लेक्चर होते माझे, त्यांचे टर्बाइन पण झाले. तुमचे डिव्हिजनचे टर्बाइन झाले.
ओके सर.
सर ही पीडीएफ तुम्ही डायरीला अपलोड केली नाही का?
पीपीटी का?
हा, येस सर.
पीपीटी नाही केली मी, नोट्स केल्यात आणि आता एमसीक्यू करणार आहे. पीपीटी ची मला वाटत नाही काय गरज आहे.
शेअर करा.
ठीक आहे, पीपीटी ची पण लिंक तुम्हाला देतो मी, काय अडचण नाही.
ओके सर.
So hydroelectric power plant. Okay, so the turbine is the device which is related to the mechanical. Now how it works, we will see where the position of turbine. Okay, if you observe here, we are going to learn about the hydroelectric power plant. Okay, if suppose this one is the dam. Okay, the dam should be built generally in रॉकी एरिया, म्हणजे ज्या बाजूला जास्त डोंगर वगैरे आहेत आणि अशा ठिकाणी आपण एक आडवी भिंत बांधतो. रिव्हर थांबवण्यासाठी एक आपण त्याला आडवी भिंत बांधतो आणि मग त्याच्यामध्ये काय होतं, ड्यू टू दॅट whatever water flowing in that river is restricted to flow due to that wall, and due to that restriction the level of water goes on increasing. Okay, it means if the level of water goes on increasing, it means it will increase the potential energy of water. Okay, हे समजलं का तुम्हाला?
हो सर.
It will increase the potential energy of water. Okay, so in water, now whatever water stored behind this dam having large amount of the potential energy. Okay, now we have to convert this potential energy into the electrical energy. Okay, which is useful. Okay, पाईप मधून जर पाणी आणलं आपण आणि बल्बला दिलं तर बल्ब आपला इग्नाइट होणार का?
नो सर.
पण हीच एनर्जी, now this energy, that potential energy or the pressure energy of water, if we convert into the electrical energy, and if we this energy transferred to the particular location where it requires at that time, it will work. Okay, for that reason we have to make some arrangement. So I think you have learned before this also. So one pipe is provided here. Okay, one pipe is provided. This one is the small pipe. We call this pipe as a penstock. Okay. And here we have nozzle. Nozzle, it means pipe, very a short pipe, and the diameter of that pipe goes on decreasing. Okay, now when see here we have one gate for the opening. Okay, when we open this gate, so what will happen, this water from the dam start to flow through that pipe or the penstock. Am I correct?
Yes.
Yes sir.
Okay, and when it start to move due to the gravitational force, it will move like this, and this pressure energy is converted into kinetic energy. Okay, here we do here this water does not exist kinetic energy because it is stored, it is stationary, so it having only a potential energy or the pressure energy. Okay, but when we open this wall and when water start to flow, at that time water having velocity. Am I correct?
Yes, sir.
Okay.
Yes.
So if the water having velocity, it means that the water consists or water contain kinetic energy. Okay, actually pressure energy is also there, but it is in small amount because the pipe diameter is small as compared to that dam. डॅमच्या जर तुलनेत बघितलं तर पाईपचा डायमीटर हा खूप छोटा आहे. त्यामुळं त्या ठिकाणी प्रेशर एनर्जी कमी होणार आहे आणि व्हेलॉसिटी काय होणार आहे, वाढणार आहे त्याची. ओके,
जास्त.
जास्त होणार आहे. सो इट मीन्स दॅट द कायनेटिक एनर्जी इज मोर. If kinetic energy is more, it means that the pressure energy is converted into the kinetic energy. Kinetic energy आपोआप तयार झाली नाही कुठून, त्यासाठी ते प्रेशर एनर्जी पासून ती कन्वर्ट झालेली आहे. ओके, सो दिस वन इज द वॉटर coming out through that pen stop. Here again nozzle is provided. So what is the function of nozzle? The function of nozzle is whatever pressure energy available here, if it is in small amount, if it is 2%, 3%, then this pressure energy is also convert into the kinetic energy, and it creates one jet. Jet म्हणजे एक पाण्याची धार तयार केली जाते इथं. ओके, which is flowing with very high velocity. ती काय होते, एका व्हेरी हाय व्हेलॉसिटीने ती काय होत असते, पुढं जात असते. ओके, त्या नॉझल मधून निघाल्यानंतर. सो इफ आय पुट ओके सिंपल थिंग, इफ आय पुट वन प्लेट in front of this, then what will happen?
तिच्यावर प्रेशर पडणार सर.
Okay, water will strike on that plate, and due to that this water will move in this direction. Am I right up to that?
Yes, sir.
Yes.
Okay, now see, up to that it is okay, that plate will move in this direction, but if we have to convert that potential energy into the mechanical energy, it means we have to rotate the shaft. Okay, once we are able to rotate one shaft with the another energy, it means we have converted that whatever energy into the form of mechanical energy. Okay, now to convert this potential energy or kinetic energy into the mechanical energy, what do we do? We place one runner here. Runner, it means one disk, suppose circular disk, and if similar type of plates, if I arrange on the periphery of this disk, now tell me, now what will happen, where this plate will move?
सेम डायरेक्शन, जिकडे प्लेट गेलते तिकडे अँटी क्लॉकवाईज फिरणार ते.
नाव ह्याच्यावरती प्रेशर होणार, परंतु ही याला इथे अटॅच केलेली असल्यामुळे ही प्लेट याच्या बरोबर ती इकडे मूव्ह होणार, अँड ड्यू टू दॅट it will rotate in the anti-clockwise direction. Okay, get it?
Yes,
If I mount now, next, if I mount shaft on this runner at the center, so what will happen? The shaft also start rotating. Correct?
yes sir.
Okay, this shaft also start rotating, and if this shaft, if I take out, it means if shaft start rotating, it means from the hydraulic energy we convert into the mechanical energy. Here we have mechanical energy. Okay, here we have mechanical energy. Okay, energy neither be created nor be destroyed, it can be converted from one form to the another form, that we have studied, but these are the applications now here. Okay, now we have mechanical energy. Now again we have to convert this mechanical energy into the electrical energy, because rotating shaft is what we can say, we cannot use that energy for general purpose. It means before that, in earlier days, this energy is directly used for grinding. It means suppose इथं हा शाफ्ट रोटेट व्हायला लागलेला आहे, याला जर मी दोन दगड एकावरती एक ठेवले आणि एकाला जर हा शाफ्ट कनेक्ट केला, ओके, तर तिथं काय होईल, गिरण चालू होईल.
सर म्हणजे आपला ते जोथा का काहीतरी असायचं सर अगोदर ते का?
हा हा, जोते आपण म्हणतो बघा, म्हणजे आपल्या गिरणीमध्ये सुद्धा ते असतात, दोन प्लेट असतात. ओके, त्यातल्या त्यातली एक प्लेट मूव्ह होत असते आणि दुसरी स्टेशनरी असते, बरोबर आहे. तशा जर जे काय जात म्हणतो आपण त्याला, ओके, त्याला जर हा शाफ्ट कनेक्ट केला तर आपण धान्य बारीक करू शकतो. ओके, म्हणजे मेकॅनिकल एनर्जीचा डायरेक्ट यूज झाला. ओके, परंतु त्याच्यापेक्षा जर जास्त युजफुल करायचं असेल तर आपल्याला ही एनर्जी इलेक्ट्रिकल एनर्जी मध्ये कन्वर्ट करायला हवी. सो फॉर दॅट पर्पज वी आर गोइंग टू ऍड वन मोर डिव्हाइस हिअर, दॅट इज द जनरेटर. When this shaft start rotating, generator converts when that shaft start rotating. So this generator converts mechanical energy into the electrical energy, and after that this energy is through the pole ahead, depot ahead, that all structure is there. So with that we get electricity, and if that electricity is transferred to the required location, it means in the industry, for home requirements, okay, for agricultural requirements. Okay, so this is total structure. Do you get this all?
Yes sir.
Yes, sir.
Is anybody having any doubt in this structure?
No.
Okay, so this one is the total structure. It means whatever turbines are there, actually there are different turbines. It means steam turbines are there, which are generally used in the thermal power plant and in nuclear power plants. But these steam turbines are having different design, and whatever included here in our syllabus, these turbines are the hydraulic turbines. Okay, for that purpose I have explained that how they work, where they situated in that hydroelectric power plant. So we are going to focus on this part, that is the turbine. Okay, now what is the function of turbine here? Now the function of turbine is that whatever energy, if suppose kinetic energy, here we have kinetic energy, so to achieve or extract maximum amount of energy from this water, to achieve maximum amount of energy from the water, okay, for that purpose the blade arrangement is there, the designs of blades are there. Okay, so this one is the turbines. Now we are going to study these turbines. The turbines function काय आहे? Can anyone
Generation.
Convert energy.
convert energy? It is mean from hydraulic energy to mechanical energy.
Mechanical energy.
Correct. So we will proceed for the next. I think you all are aware now how hydroelectric power plant work. Now hydraulic turbines. Hydraulic turbine is a machine. Hydraulic turbine is a machine which converts the pressure and kinetic energy of water, called hydraulic energy. Okay, water contain two types of energy: pressure energy and kinetic energy. Whenever water is stationary, water having potential energy or the pressure energy, and when it is start to flow, it having kinetic energy also. Okay, so the turbines are the device which converts hydraulic energy into the mechanical energy. Then mechanical energy is further converted into electrical energy by electric generator. Then hydraulic turbines are efficient. As compared to the others, hydraulic turbines are efficient, low wear and tear, because there is no any heat generation in these plants. So there is a very low wear and tear, easy of maintenance. Then high capital cost, but the capital cost, okay, you can build nuclear power plant, you can build thermal power plant, but to build the hydroelectric power plant, it is not that much of easy. Okay, it is these plants are very bigger plants. Am I correct?
Yes.
So for that required very high capital cost. Okay, that. Now this one is the classification according to head and discharge of water available. There are three types of the turbines. These three turbines are working on the high head, second one is on medium head, and third one is at low head. Low head म्हणजे डॅम मधलं पाणी किती उंचीवरती आहे त्याला आपण हेड म्हणतो. ओके, then according to position of shaft, it means position of shaft is horizontal and another one is the vertical. Inclined वगैरे असं काही नसतं, एक तर horizontal किंवा vertical. Okay, according to names of investor. So investor given their name to the turbine that they have invented. Okay, according to that, first one is the Pelton wheel, second one is the Francis turbine, and third one is the Kaplan turbine. Okay, so these three types are there, which are very important and main types. Then first one is the Pelton turbine. This one is the diagram of Pelton turbine. Is that visible?
Yes, sir.
Now it is visible. Okay, so observe this. There are two turbines. या ठिकाणी दोन टर्बाइन ठेवलेले आहेत. हे एक टर्बाइन आहे, याला शक्यतो रनर म्हणतो आपण सगळ्यांना. हे टर्बाइन आणि इथे एक ठेवलेला आहे. So these are the two turbines. And here at the center, shaft is provided. So this shaft is connected to the turbine, and another end of this shaft is connected to the generator. Okay. Now see here, this one is the schematic diagram of Pelton turbine. Okay. So I will explain construction and working of this diagram. So before that, you please draw this diagram. Okay. Draw करताना सगळेजण आता ही डायग्राम काढून घ्या समोरची. मी तुम्हाला याचं कन्स्ट्रक्शन आणि वर्किंग सांगतो.
येस सर.
ज्या वेळेला कंप्लीट होईल त्यावेळेला मला चॅट बॉक्स मध्ये एक मेसेज टाका.
झालं सर.
Okay. So we will see construction and working of this Pelton turbine. Now observe here. I will tell construction. We go from this shaft. So here one shaft is mounted, which is balanced by the bearings. Okay, on two side bearings are provided. On that shaft, runner is fixed up. It means when runner rotates, shaft also rotating. On the periphery of that runner, bowl shape buckets are mounted. We call it as buckets or pins. Okay. These buckets are mounted on the periphery, and these all buckets are equispaced. म्हणजे equal distance वरती ते runner वरती mount केलेले आहे. So this runner is covered with the casing. So this total is a casing. Now, what is the function of casing? The function of casing is to avoid the splashing of water. म्हणजे या बकेट्स वरती पाणी पडल्यानंतर ते इकडे तिकडे जे उडतंय ते अवॉइड होण्यासाठी आणि ते थांबवण्यासाठी किंवा तिथंच थांबण्यासाठी हे केसिंग प्रोव्हाइड केलेलं आहे. ओके, सो दिस वन इज द penstock. Penstock is provided to transfer water from dam towards the turbine, and it also work as energy converter, that is pressure energy to kinetic energy. One sphere arrangement is here. This one is the sphere. One more part is there, that is the nozzle. Here one nozzle is provided, so the diameter of nozzle goes on decreasing. It means that nozzle is a very important component which again convert pressure energy into the kinetic energy. Okay, so sphere is provided here. That sphere is used to stop the jet. Whenever we have to stop the jet here, at that time by rotating this wheel, if we rotate this wheel, with that the sphere can move in forward and reverse direction. Okay, या ठिकाणी हा या डायरेक्शन मध्ये, इन दिस डायरेक्शन मध्ये किंवा या डायरेक्शन मध्ये मूव्ह होतो. ओके, ज्या वेळेला आपल्याला हे जेट थांबवायचं असतं त्यावेळेला आपण हा पुढे मूव्ह करतो, ज्या वेळेला जेट वाढवायचं असतं त्यावेळेला पाठीमागे मूव्ह करतो. द डिफ्लेक्टर इज युज्ड to measure the diameter of that jet. Now why it is necessary to measure the diameter? So there are so many bigger problems are there, that calculations are there. By using this we can find out the efficiency of the turbine. Okay, but it is not included in our syllabus. Then braking jet, one more jet is here. This one is the braking jet. So this braking jet is provided to flow of water in opposite direction on the turbine. So why it is necessary? When we have to stop turbine in emergency, at that time jet is not like that. Okay, it will flow like that. डायग्राम मध्ये दाखवलेत ना, असे टिपके टिपके लिहिलेले, असा जेट नसतो, हा एका स्ट्रेट लाईन मध्ये असतो. like this it strikes on the middle point of the bucket. Okay, and in that bucket splitter is provided at middle. Due to that, the jet will divide in two parts. Okay, I will show you videos so it will more clear you. And when we have to stop this turbine, at that time we can rotate this wheel and stop this flow, but due to the inertia in the runner, it will not stop suddenly. For that, if we have to stop in minimum time, we have to start this braking jet. This braking jet strikes on the bucket from in opposite direction, so it will help to stop this runner. Okay, so this is construction. Now working is very simple. Now I think you have idea about the working. Water come from the dam in this direction. So pressure energy here, pressure energy is converted into the kinetic energy. Again, if some pressure energy is available with the water, it again converted, that small amount of pressure energy is again converted into the kinetic energy. So here available energy at the turbine is in the form of only
Kinetic energy.
For that purpose, now listen carefully. For that purpose, we call this turbine as impulse turbine. लक्षात ठेवा, टर्बाइनला अवेलेबल असणारी वॉटरची जी एनर्जी आहे ती फक्त कायनेटिक एनर्जीच्या स्वरूपात असते, म्हणून त्याला आपण काय म्हणतो, इम्पल्स टर्बाइन. ओके, दुसरी गोष्ट, इथं जो अवेलेबल असणारा फ्लो आहे, तो टर्बाइनला कसा आहे बघा, टँजेन्शियल आहे. कॅन यू ऑब्झर्व हियर?
Yes, sir.
The flow
Sir.
is tangential. So the Pelton turbine are tangential flow impulse turbine. समजलं तुम्हाला? MCQ मध्ये विचारू शकतात असं.
सर रिपीट करा सर.
हा, ज्या वेळेला, मराठीमध्ये सांगतो आता एकदम, ज्या वेळेला टर्बाइनना स्ट्राईक होणारं वॉटर हे फक्त त्या वॉटर बरोबर फक्त ज्या वेळेला कायनेटिक एनर्जी असते, त्यावेळेला त्या टर्बाइनना इम्पल्स टर्बाइन म्हणतात. हे तर समजलं?
येस.
दुसरी गोष्ट, हा जो जेट आहे हा टर्बाइनला टँजेन्शियली स्ट्राईक होतोय.
येस.
टँजेन्शियल म्हणजे समजतं तुम्हाला? पहिली महत्वाची गोष्ट, एक वर्तुळ आहे, त्याच्या भोवती स्पर्शिका गेली की आपण त्याला टँजेंट म्हणतो. ओके, तसं या हा जो टर्बाइन आहे हा टँजेन्शियल आहे. हा टर्बाइन कसा आहे? टँजेन्शियल टर्बाइन आहे. So when water comes here, it having only kinetic energy and it strikes on the bucket. So that water divides in two parts, and due to that energy of water, this runner start rotating. When runner start rotating, it connected to the shaft, then shaft also start rotating. It means hydraulic energy is converted into the mechanical energy, and this shaft is connected to the generator. This arrangement is not shown in this diagram, okay, because this is only for the Pelton turbine. So this mechanical energy is again converted into the electrical energy. Okay, so this is only simple working of that Pelton turbine. And whenever we require to stop this turbine in emergency, for example, some buckets are loose, if you found that, okay, some vibrations are there, At that time, if you have to stop this turbine, so what do we have to do? We have to stop this flow, main flow. And when we stop this main flow, another pipe is connected to that braking jet, will start in opposite direction. So braking jet start in opposite direction. So it will take minimum time to stop the turbine. Okay, is anybody having any doubt? Yes. Okay, you can observe here animation. Animation दिसतंय तुम्हाला? का slide change नाही झाली?
नाही सर.
नाही सर
No,
झाली
sir.
नाही सर.
आता होईल.
Yes, sir.
हा झाली
झाले ना चेंज? पण अशी रन होत नाही. 1 मिनिट त्याला जर मोठं करतो म्हणजे रन होते. Now you can observe here. आता होते ना animation दिसते?
नो सर स्लाइड दिसते
रन झाले दिसत नाही काय तर?
दिसतंय
नो
सर.
सर
तुमच्याकडे काहीतरी प्रॉब्लेम असेल. सगळ्यांना प्रॉब्लेम दिसते का कोणाला दिसत नाही?
नो सर दिसत नाही.
No, sir. Diagram.
No, sir.
ठीक आहे राहू दे. आपण काय करू डायरेक्ट व्हिडिओ बघूया म्हणजे अजून जास्त क्लॅरिटी येईल. सो दिस वन अशा प्रकारचे हे बकेट्स आहेत बघा. हे मॅन्युफॅक्चर केलेले हे असे जोडलेले आहेत जवळजवळ. त्याच्या बरोबर मध्ये इथं बघा स्प्लिटर दिसतो. स्प्लिटर दिसतोय हा?
Yes, sir.
हा, तर वॉटरचं जे जेट आहे या स्प्लिटर वरती बरोबर मधोमध स्ट्राईक होते. त्याच्यावरती स्ट्राईक झाल्यानंतर म्हणजे आदळल्यानंतर ते 2 भागामध्ये डिवाइड होऊन त्याच्यावरती स्लाइड होऊन त्या बकेट मधून परत बाहेर पडतो. ओके, सो I will show you one video. One second. Is that visible?
Yes, sir.
Yes, sir.
Okay.
येस सर
So this one is the 3-dimensional model of a Pelton turbine. Okay. So this one blue color shows buckets of the couplant turbine. Couplant turbine. And white color shows runner. This one is the runner on which that buckets are mounted. The shaft is provided or shaft is attached at the center of runner, which is balanced with the bearing for smooth running. Okay, here we have penstock. This which color? This one is, I think, yellow. That yellow color is the yellow color is of nozzle. If you see, observe here, you can observe here that area of nozzle goes on decreasing. It means if the area goes on decreasing, it converts pressure energy into the kinetic energy or velocity. It will increase the velocity. This is how jet, this one is the jet, it how strikes to the bucket of Pelton turbine. And the striking of bucket at a required location, it means at the center of that bucket is very important. Then and then only we can extract maximum amount of energy from the water. If you observe second diagram, okay, if you observe second diagram, then you can see there the jet is not striking, or the 100% jet is not striking on the bucket. That 50% here, that 50% jet leaves without striking to the bucket. दिसतंय का बघा इथं? Yes.
Yes, sir.
50% jet move in forward direction without striking. Then here total jet is moving without striking. It means we cannot extract that kinetic energy, or we cannot convert, or the turbine cannot convert that kinetic energy into the mechanical energy. So for that purpose, the arrangement of turbine and the jet, or the bucket and the jet, is very important. So then and then only we can extract maximum amount of energy of water, and then we can convert into the mechanical energy. So the buckets are very important component. It is very difficult to design buckets. So this one is the single bucket shown here. So two ball types are provided, and one splitter is provided at the center. So when jet strikes on the splitter, it divides into two parts. And when it divides, it glides over the ball-shaped bucket and then move outside. Okay, so that beta angle, alpha angle, that velocity in this is related to the mathematical calculations, but with the mathematical calculation is not in our syllabus. So there are different terms. That is, velocity triangle is very important for this, to learn this, to achieve the or to calculate the efficiency of the turbine. So velocity triangles are there. For pump also, to calculate the efficiency of pump, we have to learn velocity triangles. In that, different velocities are provided. So the water energy available at the bucket is in the form of kinetic energy. So these turbines are the impulse turbine. Okay, pressure energy is also zero, and that bucket energy, it is not required. So only whatever force here available is the kinetic energy. So these turbines are impulse
turbine.
Yeah. That bucket velocity, it means inertia, due to inertia. Okay. When we have started that, actually it is not part of the syllabus, but when we start the jet, at that time, it required more force to move that jet, to move that bucket. Okay. When it start rotating, and after second or third or fourth, or when it rotates one cycle, for next, when it comes in front of jet, after one round, it does not require that much force. Do you get what I am talking? पहिल्या सुरुवातीला त्याच्यावरती जेवढा फोर्स आपल्याला अप्लाय करावा लागतो रोटेट होण्यासाठी, त्याच्यानंतर तिचं एक रोटेशन किंवा दोन रोटेशन झाले म्हणजे त्याला इनर्शिया एकदा मिळाला की परत त्या जेटला तेवढा फोर्स लावावा लागत नाही. Get it?
Yes.
Yes, sir.
So
Yes, sir.
this is the related to actual velocity and relative velocity. Okay, so the actual velocity is the different and relative velocity is different. Then there is another velocities also, whirling velocity. Okay, so whirling velocity is also there, but it is not our part, so leave it. We only see how it works. So this is related to this graph, is also related to this. Okay, so the working of Pelton wheel is very simple. Is anyone having any doubt in that? कोणाला काही शंका आहे का?
No, sir.
म्हणजे सगळ्यांना समजलेलं आहे.
Yes, sir.
तुम्हाला एक मी असाइनमेंट देणार आहे. तर त्या असाइनमेंट मध्ये तुम्ही काय करायचं आहे लिहून घ्या पाहिजे. तर असाइनमेंट नंबर 1. Assignment number 1. In that you have to draw all the diagrams, only diagrams. And when you complete to draw these diagrams, after that you have to write MCQs that I will provide you, and you have to write. Now you write 30 MCQs, 30 MCQs on. You can choose tentative.
तर म्हणजे कोणत्या कोणत्या डायग्राम काढायच्या?
All diagrams, only diagrams. लिहायचं वगैरे काय नाही, डायग्राम काढायची आणि त्याला नाव द्यायची व्यवस्थित. You have to
Separate
draw
notebook
all the
मध्ये ना
diagrams. Yes.
सेपरेट नोटबुक मध्ये ना.
तुमच्या आताच्या नोटबुक मध्ये जागा आहे का?
जर आम्ही नोट्स रेडी करताना डायग्राम्स काढलेल्या मग त्या चालतील का?
नाही ना, त्या नाही. एका खाली एक सगळ्या डायग्राम काढायच्या, त्याचे फोटो काढायचे, त्याचे PDF बनवून ठेवायचे तुमच्याजवळ, आणि मी तुम्हाला लिंक देतो, त्याच्यावर तुम्ही ते सेंड करायचे.
ओके.
ओके सर.
मे बी आज संध्याकाळी तुम्हाला मी MCQ, आज संध्याकाळी किंवा उद्या सकाळी तुम्हाला मी MCQ प्रोव्हाइड करतो. त्यातले टेंटेटिव्ह 30 MCQ तुम्ही लिहायचे. ओके.
सर नोट्स मध्ये कन्स्ट्रक्शन मध्ये कंपोनंटचे फंक्शन पण लिहायचेत का?
कशामध्ये?
नोट्स लिहिताना कन्स्ट्रक्शन आहे ना, त्याचे कंपोनंटचे फंक्शन पण लिहायचे का?
तुम्हाला कसं सुटेबल वाटतंय ते बघा. तुम्हाला स्टडी करायचा त्याच्यानुसार तुम्ही क्रिएट करा नोट्स.
ओके सर.
ऍज पर युअर कन्व्हिनियन्स.
तर असाइनमेंटला वेगळी नोटबुक करायची ना?
नाही, त्यातच लिहिलं तरी चालतंय पाठीमागून. जर तुमच्याकडे मोठी नोटबुक असेल आणि त्यातच पाठीमागून लिहिलं तरी चालेल, नसेल तर तुम्ही नवीन केली तरी चालते. मला फक्त ते स्कॅन करून, एका खाली एक असलेल्या स्कॅन करून मला PDF पाहिजेत शेवटी. त्याच्यावरून तुम्हाला मार्क्स द्यायचे आहेत, इंटरनल मार्क. ICA, इंटरनल कंटिन्युअस असेसमेंट. ओके. तर सगळ्यांनी डायग्राम काढायला चालू करा आणि डायग्राम काढून तयार ठेवा. मी MCQ देतो आज उद्या. MCQ पण त्यातले लिहा. MCQ लिहिताना असे लिहायचे की प्रत्येकावरचे थोडे थोडे आले पाहिजे, चॅप्टर कव्हर झाला पाहिजे तेवढ्या. ओके. इफ यू राईट मोर दॅन 30 देन इट इज वेल.
येस सर.
Is anybody having any doubt now?
नो सर.
सर डायग्राम नंतर MCQ लिहायचे का?
हा. अगोदर डायग्राम काढा मग MCQ लिहा त्याच्या खालीच.
ओके सर.
व्हेरी सिम्पल टास्क. ओके. खूप सोपा टास्क दिलेला आहे मी तुम्हाला, काहीच अवघड नाही याच्यामध्ये. Okay, so all of you please put your attendance into the chat box. We have 1 minute only. I hope you all have written your roll numbers. So with this we will stop here. There's some more remaining. Now I think all are over. So with this we will stop here. We will meet in tomorrow's lecture with the another turbine, that is Francis turbine. Okay. So thank you all of you.
Thank you, sir.